All right, so welcome everybody to the session about demonstrators. So we have in OntoCommons today about 1.5 hours to discuss how to use ontologies in different application fields, and particularly, well, my name is Fensel and I'm chairing this session here. So we have this following agenda. First, we have 3 presentations which will show particular details about demonstrators and how ontologies are being used. And there was already a FAIR session about FAIR technologies, which you may have been before lunch, chaired by my colleague and Umuchan Simsek. And here we are more discussing practical issues, well, which have to do with general issues of ontology use, not only on FAIR data. And we have 3 demonstrators. So the one from, well, two first demonstrators are from, at least on the agenda, are from already OntoCommons partners from BOSCH and from TEKNIKER, and demonstrator from BOSCH will be on showing how the ontologies are being used in manufacturing, and demonstrator from TEKNIKER will go into material science or material science kind of production and use of ontologies there. And presentations from Jasper Koehorst from Wageningen University of Research and Research will be on showing the toolkit and enabler on how to make data, particular research data, semantic and fair. In between of every demonstrator, we have possibility to ask questions and answers, and also we have a discussion at the end of the presentation. Now we have a kind of a small agenda change, so we don't have the exact order, so we will start with Iker, and then we go to Jasper, and then we go to Evgeny because he had some issues and he would join a few minutes later. So for the session, we, well, as you already know, the project is recording these sessions, and for archiving purposes, because we also use this kind of sessions to get additional feedback and insights on the fields, the work we are doing. And you can, when you have any questions at any point of time, you can type them in the chat, and or in questions and answers, and you, when there are any comments, you can type them in the chat. So this is how we will proceed. Actually, Evgeny is here, so I think we can just follow the order, right? Mm-hmm.
Yes, sorry.
So we don't change the announced order.
Yeah.
Okay, that's better because maybe somebody wants to go between the sessions.
Okay,
then I suggest we start directly then with Evgeny, and that he shows what the demonstrator is doing. I stop my screen sharing.
Let me start the screen sharing. Do you see my screen?
Yes.
Right, measuring the impact of industrial ontology application. So today, what in this short talk, what I will say is how can we understand that ontologies, they do make some difference in industrial applications, and how I would like to do it. So in the current use cases we have in OntoCommons, we are still developing the use cases, and the project is lasting for 3 years, and we are getting ready to show the real impact with BOSCH and other use cases. So what I would like to show today is the few use cases where the impact has been really astonishing, so with really strong impact, and that can show what we can expect from ontology applications in the use cases of OntoCommons. So let's just give me a couple of examples. These examples, they are coming from the experience of my project that I was involved in, or from other colleagues from the Series Research Center at the University of Oslo, and other interesting use cases that I know about. So there will be a sequence of use cases. So Able, it's a really nice example where the company builds oil platforms, these huge beasts, and they use semantic technologies to enhance design, like this 3D design of those platforms. And there, the design goes down from hours and days. So, and the design goes down, and they save for hours and days on this design and verification. So whenever you construct such a 3D design, you can click verification button, and since there is an ontology behind this design, the system can automatically derive for you various aspects, various conform to international standards. So this is a really nice way of saving a lot of time in the design and in the verification. Another example is from Statoil or Equinor, the new name of the company. They use platforms. Well, some of them built by Able, some of them built by other companies. And there, there is one of the issues is the data access challenge, where the data is in various databases. For example, there is a big database with 700 terabytes developed for many years with thousands of tables and tens of thousands of columns. Accessing this data is really challenging, and in order to find something in this database, it takes a lot of time. With the help of ontologies layered on top of this database, or the Schlegel huge database, one could get access to this data much faster. So the data access went from days to hours. This is the real big impact that has been done, and one can get these beautiful diagrams or dead diagrams through this ontology-based access. Another example is from Siemens, where the idea was to improve diagnostics of turbines with the help of semantic technologies. So remote diagnostics of complex equipment like turbines went from hours to minutes. One can write diagnostic tasks, reuse diagnostic tasks from the catalog, where the diagnostics is written with the help of ontologies. Why? Because one can abstract from various details of turbines towards ontologies and then write diagnostics on top of ontologies. This was a very nice and very successful thing that was done a few years back, and actually I was involved in that. We even got a best paper award for that. It was a very nice impact we showed in terms of these remote diagnostics. Another impact is in Festo, that together with Uni Oxford, we're developing a semantic solution to help configure things like that, where you would like to get a complex this Cartesian system, for example, for manufacturing, like a conveying line or something. To do that, to configure the system, it can be configured out of thousands of basic components and millions of drivetrains. So we're talking about billions of combinations, which is really difficult to do. And relational or classical database technology is good, but it's not as fast. With semantic solution, and in particular developing a large ontology, which is big ontology with hundreds of thousands of axioms, the configuration went from hours to minutes of those complex systems. In BOSCH, we also use ontologies in various ways, for example, for data integration on top of manufacturing data, and the semantic data integration helps to put data together, going from hours, days to days, minutes. Another example of impact, for welding machines, you'd like to predict quality of these machines, so they connect pieces of metal together, and so this they do these kind of connections. And there, together with the PhD student, I worked with in BOSCH. So we developed methods to layer ontologies on top of the data from welding machines to help understanding quality of welding operations, and this made a big impact. So here, and this is actually our use case in OntoCommons. So here, in order to predict quality of welding operations, one has to go through this pipeline of tasks, task negotiation, data preparation, feature preprocessing, machine learning modeling, and so on. And there is a number of challenges in communication, data integration, generalizability of machine learning models. And all of that can be improved with ontologies. So we layered ontologies on top of that, on over this pipeline, and these ontologies like the core ontology for task negotiation, then some domain ontologies for data integration, and so on. And so they could be extended with some other like packaging ontologies if you go to another production things, machine learning ontologies as well, and this can help also to form machine learning pipelines also in the ontological form and store them. So all of that on top of the welding data help us to do machine learning based analytics for welding operations, and it goes again from days to hours, this impact. So in terms of measuring the impact, I can say that the yardstick that we could use, and actually maybe the most valid one, is to do calculations in some these objective measures like days, hours, going down to minutes. One can also convert this into money, because always whenever you save time, you can always calculate how much money you saved on that as well. But money it's I say less obvious, because when you say a million, is it a lot or not? So it depends. But when you say that you save time from days to hours, or hours to minutes, then it's much easier to understand, because when you say this time saving, you can understand that in a large company, if you go this way down in time, and then you scale it across multiple factories, multiple players, then the impact would be really drastic, because we're talking about one particular analytic case, for example, where we save a lot of time, and in terms of thousands of analytical cases, then it will be a lot of savings. So the impact is tremendous as soon as we can get it nailed down to very concrete terms, for example, time saving. And then one can convert it into money, and then it depends on each and every organization how to turn time saving into money saving. Ontologies do help to save a lot of time, as you've seen through a number of examples. This is what I'd like to say about the measuring the impact of ontologies in use cases here. Anna? Hello. I cannot hear you.
Hello?
Oh, yes, now I can hear you. Yes. Okay,
so this was the presentation, right?
Mm-hmm.
Okay, thank you very much. Are there any questions from the audience? Basically, again, well, you can post it in the question and answer slot.
Mm-hmm.
Do you think, well, you emphasize quite a lot in the talk that the time is very well perceivable criteria for success of ontology deployment, or maybe any kind of technology deployment in the demonstrators. Do you think it applies to all demonstrator scenarios in OntoCommons, for example, or maybe in some areas it can be more difficult to take this as a most important criteria?
I think that the time it's quite a universal criterion. How can we say that there is an impact? If we say that there was technology A before ontology, now we bring ontology in, and now we have technology B, and then well, how can we say that ontologies do make an impact there? So the tasks that people were trying to solve with old technology versus the tasks that we could compare, we can see how much they invested in solving the problems using old technologies, and how much they benefit with the new technology. Time is really universal, because in terms of the money, if we put price tag to each of these use cases that I've just mentioned, then it will be difficult to understand. For example, in one case it's 1 million saving, in another case is 1 billion saving. 1 billion, is it a lot or not? Well, it seems to be a lot, but actually 1 billion could be a lot, but it's just a lot because there are a lot of instances of deployment of a system, and in every instance when you use ontologies you save maybe 10 cents, but there are so many deployments, then you save a lot of money. In another case, it's just one deployment which saves you million, and then basically when this multiplication factor on how many instances of a particular deployment you use, that's one either put this as well into account, or it's easier if you say that in time, in terms of the time, it is a much easier way to understand. And then basically, if you say that how much time you saved, for example, on either welding diagnostics or say this turbine diagnostics. So you see how much time you save on diagnosing one particular turbine. From that, one can get an estimate how much time you would save if you go from one turbine to thousand to millions turbines or millions of turbines. So that's if you say that you saved 100 euros on diagnostics of one turbine, then it's unclear what this 100 euros mean. Is it a lot or not? Maybe yes, maybe not. And then if you go from one country to another, then 100 euros can be in one country, $20 can be in another country, 1,000 rupee can be in another country. So, but if the time it's quite universal, it's free from this price of the that you have to spend. For example, the hourly rates and other things are kind of in this case they're hidden, and what you see is the time, which is the critical thing. And also in OntoCommons, we go from the idea that OntoCommons help to go from some ontologies into standardized ontologies, and this is what we can also show that before ontologies, the problems were solved in X time. After ontologies came in, there is this half of X or 10% of X or some hours saved on this with the semantic technologies. But when you use standardized semantic technologies, then one could show how this make another impact, that you are able to save another few hours in every task because the ontologies are standardized and they become somewhat easier or better to perceive or in some other ways. And that could also show that the standardization that is delivered through OntoCommons, for example, how this can help as well. Yeah. But if you go from OntoCommons in general to semantic technologies, then the time is really a universal way of measuring things. Yeah. For me, it's hard to think about other measures which are which you can use to unify the impact across all these applications.
Yeah, of course. If the process is already established and you're doing the same thing all over again, and then you can compare them. But if, for example, you're defining something else which did not exist before, then you cannot compare the time to what was there before, because maybe you identified a new process, a new product, and then it's again adds value, but it's something what was not done before. I was thinking about this scenario, yeah, maybe.
That's a good question. If you're kind of in a greenfield scenario where there is nothing before ontologies, and now you came with ontologies and try to solve a problem that was not addressed before, then the impact, in this case, the impact will be of a solution. So whether it's ontological or some other solution, and then the measuring of impact could be, say, the effectiveness. So before there was the task was not addressed at all. Now the task is addressed and solved. Ontologies help, but whether ontologies are good or not would be difficult to judge, because if you use instead of ontologies, say, relational database solution, you may also get a success rate. So you can succeed with a new task with ontological or relational solutions. And to say that the ontologies are the ones who give some good benefits would be hard to say if there is no other old technology to compare with. Yeah. So in the greenfield scenario, it's actually more difficult to do the judgment, I would say. Yeah.
Okay. Do we have more questions? Then thank you. Let's then move to the next speaker. Next speaker is Iker Esnaola from TEKNIKER. And the title of the talk is Characterizing Tribological Experiments, Current Status and Impact of OntoCommons on TEKNIKER Demonstrator. So we are moving more from manufacture a bit more into science. And Iker, go ahead.
Okay, thank you, Anna. So, well, as you said, this demonstrator is more focused on tribology science. So, well, first of all, well, I'm Iker Esnaola. I come from TEKNIKER. I'm a researcher and also the coordinator of artificial intelligence here. We are a research and development center located in the north of Spain, in the Basque Country, and we have more than 40 years of experience on applied research. And what we try to do is to improve the competitiveness of our clients through the transfer of technology. We are specialized in manufacturing because, well, historically the manufacturing has had a very strong presence in the Basque Country, but we are also experts in other domains like the tribology. So what is the tribology? The tribology is the science that studies interacting surfaces in relative motions, such as in bearings or gears. Well, the tribology is a key enabling technology for developing new products and also for driving new materials into sustainable solutions. Anyway, well, of course, in order to know how a given material will behave, it's necessary to perform some experiments. Now, the problem here in this domain is that there is a lack of standards. I mean, different companies may document their experiments in different ways using different formats and different data structures, data models. So having this heterogeneous information, it's not easy to access them. And sorry, and that's what we try to do in this demonstrator in OntoCommons. We try to help tribologists to find these experiments, um, and of course, this way shorten the time, the number, and the size of experiments they need to perform in order to understand the behavior of a given material under certain conditions. Because the problem is that many times tribologists perform experiments that have already been performed, if not the same, very similar, but they cannot access this information because, as I said, it's they're not using standards. So in this case, we are using semantic technologies as one of the main drivers or technologies that will help us achieve this goal. And I was sorry, I also wanted to comment that this demonstrator is connected to the iTribomat project, and also the data sources that are available in this project. So which is the approach that we are envisioning? Well, we propose using a common representation for the tribological experiments. Not only that, also with the use of ontologies and semantic technologies in general, we think that we could enrich the existing data, the experiments, with additional knowledge that could also help to well, improve the representation of the experiments. And for that, for helping the tribologists, we propose having an ontology-based data access, just in a similar way to the use cases that that Evgeny has just presented. So that way, we would have a layer that somehow abstracts from the underlying heterogeneous data sources, and we would have a homogeneous access to this data. So here you can see well, a schema that could help for well, for explaining our approach. So the idea is that the tribologist would work directly with a user interface, and this user interface somehow abstracts the user from the underlying technological details. So well, also the idea is that the data would still be in the original databases, mean, we are not trying to extract that data and put it in an RDF store, but instead we want to keep it in the original databases and implement somehow federated search service. So this is what we are currently doing in our demonstrator. So which are the benefits of being part of OntoCommons? Well, first of all, to cooperate with partners that are having similar requirements in other demonstrators. Well, this cooperation also helps to at times share the sorrows, or find some understanding from other people that are dealing with similar problems. One of the other interesting points is that we are receiving support from experts in a wide variety of domains, like in materials and also ontology engineering. And we also get to know related ontologies, domain level ontologies, that we would otherwise have difficulties to get to know, so that we finally can make these alignments with these ontologies and contribute to having this harmonized ontology ecosystem, which is one of the goals of OntoCommons. And as I said, we are currently working on this demonstrator. We have already identified the requirements, or which is the information that should be represented in each tribological experiment. We are also in conversation with similar demonstrators of OntoCommons, 3 other demonstrators. And well, once we coordinate somehow, we are able to join forces. We are planning to extend some existing ontologies to cover these new requirements that we have already identified for the tribological experiments that we are trying to characterize. Well, these are the current fairness metrics or indicators that we have for our demonstrator. Well, they are very much related with the the fair principles that have been explained and discussed in the session during this morning. And well, we, even though right now the fairness level is rather low, we do have quite high expectations, and we are expecting to improve these metrics. Well, especially because we are relying on ontologies, and also, well, as one of the speakers this morning said, the fairness KPIs are, I think it was the 90% of the time, are about metadata. And I think, I mean, since that's one of the main requirements to improve these fairness metrics, I think we can improve them. And once we are done with the demonstrator, once we achieve this objective that I have just presented, having access to different, to experiments stored in different databases in an homogeneous way, we are expecting to reduce the times, and of course also the resources needed to develop new materials. So in terms of resources, and time, in both aspects, we are expecting to reduce 20%, which is quite a lot in this case. And yeah, that's all from my side.
Mm-hmm. Thank you very much for the presentation. Other questions from the audience? Okay, maybe. Would you agree with the previous speaker about the criteria? Because well, you also mentioned time is important on this. Or would you also think there are also other criteria which should be explicit when you evaluate the effectiveness of technology use, or how to convince people that they really should apply this?
Well, yes, if I think time is one of the easiest way or more obvious to the people. Just like yeah, the previous speaker said, if you are able to reduce your, in this case, experiments from months to days or from days to hours, it would be great. Especially here, the thing is that you probably need to perform a set of experiments to get to know the behavior of a given material, because you may need to make an experiment, then analyze the results, then try to uh, tune a little bit the parameters you are using for the experiment. So it's quite uh, costly in terms of time to get to know the behavior or the tribological behavior of a given material. So with this approach, if you are able to at least discover similar experiments that have already been performed, you will be able to fine tune better or design better in a more accurate way the experiment you are about to perform. So I think that's a great help for the tribologists, which nowadays they simply rely on their previous knowledge, on their experience, and also on the literature, which many times they don't use either a standardized um, way to document these experiments. So yeah, I think definitely the reduce in time, it's one of the one of the greatest ways to convince them.
Mm-hmm. Because in this case, well, that you also have users involved and they have to interact with the system, also using also graphical user interfaces. Do you have challenges with this? That of course, well, technology helps, but if people cannot use it in a good way or spend a lot of time to get to learn it, and this is also kind of
Yeah, I
difficult.
think I think that, that's another challenge. We haven't still started with this graphical user interface, but yeah, definitely if this is the way the users will access and will use this solution, we need to put a lot of effort on making it intuitive, easy to use, and appealing also for the users, because otherwise I mean it doesn't matter how good your solution is if they if in the end of the day they don't use it, it doesn't make any sense. So yeah, we should put a lot of effort on that.
Mm-hmm. There is a question from the audience. And it says, dear speakers, so it's maybe to all speakers, as you mentioned, time is an easy way to measure impact of using ontologies. Therefore, would you say that ontologies are a tool that would benefit larger companies more than SMEs?
Well, not necessarily. I think SMEs could also benefit from this type of solutions. I mean, I guess that time saving is important for large companies and also smaller ones. It depends on the process that you are dealing with. So I think both types would benefit from it.
Actually, it's a good question. For whom the time was more valuable, for smaller or bigger companies? On the one hand, in bigger companies, clearly, if you save time in one operation and this operation is performed thousands or millions of times across the company, it will be like a huge amount of money if you sum across all of these operations. But at the same time, small companies, they and for them the time is vital. Maybe for them the time is vital to survive, because they don't have that much money. They have to do things fast in order to kind of survive, to get new contracts and move on. And big companies, they may be able to afford the longer time as well. So it depends. I guess it may not be so much depending on the size of the company, but on the, say, on durability of the company, in the sense that how long it, how much time, how much waiting time of concrete things it can afford. For example, if you do something, then concrete, say, analytics, and this analytics is that expensive that the small company just will get bankrupt until the analytics will finish. Then obviously the small company will be more dependent on this time. So I think that it's important for both organizations, and this is case by case. One need to understand for whom the time is more valuable, for the smaller or the bigger companies. And of course, the time one can also then convert into towards this CO2 neutrality trend that is like really big one nowadays. And the more time you save, the more CO neutral you are, because you spend less resources on computing resources, less electricity. Then you may produce less waste during the time that something is happening. So if you can do faster diagnostics in manufacturing, then you can prevent errors faster if you do predictive diagnostics. So all of that things also not can, but I guess should be converted into this particular company specific other dimensions which are beyond the time. When you say that you save time on something, then on some particular operation, then one can also enumerate the impacts of this save time. You save time on predicting low quality operations. One could then convert it in how much resources have been saved because this operation has not been performed. You predicted in this operation in advance. So that's the time is like the baseline, but this can naturally be converted to 5, 10, 20 like resource saving, CO2 reduction, and other parameters can be unfolded for a particular concrete company. So that's, I would say, the time is like something that can be opened up, and then dozens of other criteria and parameters could be highlighted for each particular use case. But at the higher level, time is a good measurement.
Thank you. Okay, I don't see any more questions from the audience, so I would suggest to move to the next speaker. Next speaker would be Jasper Koehorst from Wageningen University and Research, and the topic would be on demonstrating the fair data station for managing metadata in the life sciences. So we move even more towards science. Jasper, I think you are.
Yeah, I'm there. So thank you for the introduction. So we'll be talking about the fair data station because in the life sciences there's a lot of data being generated, and I am part of an infrastructure of the unlock system where we work with microbial systems. So these microorganisms that do all kinds of interesting things for nature, for your human gut, for health, and for the environment. So during this research, it can either be an academic level, but also at industrial level. There's a lot of samples being collected, research being performed, experiments being done. And often what is always lacking is the metadata that belongs to the information that's being generated. So it is actually crucial that during a research project, we follow them along. When you take your samples, when you try to answer a scientific question, or when you try to optimize a bioreactor for the industry, we need to capture the metadata management. So we have this 4-step process where when you think about your project, when you think about your experiment, there will be this form generation procedure that the scientist, along the time when it's doing the experiments, can continuously update this information. So when it takes a particular sample from the sea or from a forest or from an internal bioreactor, this information is captured, but it can also be continuously updated. So that, for example, the temperature or the pH, the time point, or at what depth or what longitude and latitude information these samples are taken. Then it's nature to humans that people make mistakes. They make typos. They don't write things down properly. So we have a continuous validation system in place that keeps track of whatever has been changed, is that according to the standards that we have agreed upon. So once this validation is passed, there will be a semantic resource based on different ontologies that then can be used for internal research, so to answer internal questions. Okay, which samples belong to which reactor, to which location, but you can also then go abroad over different projects to ask within our SME or within our company, what projects are being performed in what area? What samples do we have in place? So we have a metadata structure in place where at the moment the highest level is your project, your funding information, what is your research question in general. And then we go into more depth, so to get more precision on what is being researched. So then we have this investigation. There we also set up the metadata, who is allowed to have access to this kind of information, so that systems that then use this metadata can then easily add users or remove users from certain investigations. Within an investigation, we have a study where you actually do where the observations are performed to answer a certain biological question. We have the observation units, which are objects such as bioreactors or fields or oceans or patients that are being sampled or being studied. And we use this according to the MAEPI ontology, which is actually a plant-based ontology, but this information can also be easily mapped to other systems. But of these bioreactors, of these patients, you take your samples. So that can be one, but it can also be thousands of samples over time, where we actually register the metadata at this point according to the Genomic Standards Consortium. So these are the official standards for genetic information, but we are also working on mapping this to social sciences or economics to make this more generic on the information that's being obtained. Then of these samples, there will be data generated so that we know, okay, this data set belongs to this sample, to this bioreactor or patient, to this study. So you can actually go into very detailed, this file that I have stored here, where is it associated with? So you can gather all this information. So we have created a website for that. So it's basically just a Java web app where people can generate these templates, but also can validate continuously what they have registered to ensure that the quality is up to the current standards. So we have a general about information page. Then you have the metadata template where you can actually start registering your information about the project information. So what is the project about? What is the title? Do you have a long description about this project that might span 4 or 5 years in running? Then within this project, you have your investigation or multiple investigations that are being performed. And each of these investigations have their own identifiers, the descriptions, the title, but also user credentials of who is allowed to have access to this particular study. So then you go to the next level, so you can fill in your study information. So what is this study going to be about? And then we start diving into the more detailed, where you cannot register things anymore, but then we start selecting metadata. What is important, for example, for the observation units? So we have a standard core package, but you can easily make new packages. For example, if you are as a research company or a company focusing on human health, you can make your own metadata package on observation units related to human metadata. So then you can specify there what is very important to have registered about this observational unit. Then we have at sample level, so you take your samples from these observational units, and there we already start incorporating these current standards from the Genomics Consortium, where they have a large variety of metadata. So you can take samples from the air, from food, from farm environments, from the human skin, also from the soil or sediments. And based on these criteria, depending on the package that will be used, metadata will change. So here we have the core metadata. We have decided this is obligatory for each sample that's being registered. Is it safe to use? What is the identifier? Where can I find it? What is the condition stored up in? But of course, you can also have air-specific metadata. So for example, what is the altitude? What is the elevation of the location where this sample was taken? So you might need this additional information when you start collecting and working with your metadata. Then we also adhere to syntax standards, and that is also being used by the validator to ensure what you've written down as an example, that is according to the syntax that is being registered, so that you always know what the metadata means. So it is more detailed, and of course in the description we will explain in more detail what we mean with this example and with this syntax, with this field. So we also have then the data sets. So currently this is with a focus on the life science on genetics. And there again, you can select different kind of data sets that can be generated in your project, and they can be automatically expanded with additional metadata fields that, depending on the kind of research fields people are working in, what kind of metadata should be captured for the data set. So for example, here for amplicon data, we have a whole list of information, the general descriptions, identifiers, names, but also the date when this data set was generated, but also, for example, where was this data generated, by which we generate these data sets often by external companies. So you would also like to register which company generated this data for us, what equipment did they use. Because it might actually be that one company might generate better results than another company. So that's also a way of comparing these things with each other. So then once you have selected whatever is important, what is needed, you already filled in your project information, your investigation. So then you say, generate my form to fill in, and it just generates an Excel file. And why Excel? Is because it's still the easiest software package that is out there where you can easily register thousands and thousands and thousands of samples. We already have multiple projects that are using this, where we have more than 2,000 samples. So then you need to have an environment where people are familiar with, but they can also easily register an entire range of information. So for example, if you have for an entire set of samples that are taken from the same location at different time points, you can very quickly fill in where this sample was taken from. So this really speeds up the process of gathering this metadata about these samples. And then of course, when a person has, let's say after a few months it collected the first batch of samples, it can then fill in this form, it can start to generate data, but in the meantime we can already start validating what has been registered so far. Is that up to the current standard we have agreed upon? So for example here, there's this sample in the first row, it just did not fill in the sample name. And according to the standard that is currently there, the sample name is an obligatory field, so the researcher needs to go back to his Excel file and fill in this information. But of course, this can also be if you fill in the altitude and you only fill in the number, but not the unit, it will also complain that it does not fit the syntax that we expect. So then the data registrator can go back and forth until the validator accepts it, and then it will generate a semantic web, an RDF data file. And that is the default output that then can be used in downstream processes, where you can actually load these data sets into your triple stores and do your querying. So this entire, all these metadata fields are back, so in the back end we have these field requirements. So that's basically what the web interface uses to adjust its metadata. So we have a general package label. So we know, is it an air sample, a soil sample, a water sample? Then we have a comment name, that's for the structure. We have that's for in the RDF. Then we have the item description, which is basically the RDFS label that is more the human readable format. Is it obligatory or not? What is the syntax? So you can see there's a regular expression that is required. An example, so to give it to the user what we mean exactly, what we prefer as a unit. So for example, if you talk about altitude, we prefer meters, but maybe this is a very low level system, so people might use centimeters, or if it's very high, you can of course think of kilometers. But we have a preferred unit. Then of course, we can already work on predicate levels. So what if this kind of predicate should be used for this kind of metadata field, and then the definition that's being used to describe what we mean. So that's basically another big table where we have here on the left, we have the package name, the structure common name, the RDFS label, the requirements, X is optional, M is mandatory, the syntax, so there we can really describe in detail what are the restrictions, and then we have the examples, and in, for example, the URL, we have the mix prefix for a certain standard. Then this entire web interface is backed by Ampusa, which is an ontology validator and code generator. So we made a skeleton ontology based on some standards, and that generates our Java API where we can program directly against, and it will do the basics of validations initially. And then on top of that, we also have the syntax validator in place to go into more detail. So this really speeds up the development process of your interface because you can directly communicate with the application programming interface. And this is then, for example, a raw dump of a sample where we have some information. We have the biosafety level is an integer. We have strings. We can have dates in there. It all depends on the syntax, what is used. And then a sample can have one or many data set, essays that contains additional data to link everything together, which makes it much easier to query this information. Of course, this is continuously being improved. We are continuously working on the development to also enable this outside of our unlock infrastructure. So we have an unlock version really focused on the life sciences, all these microbial communities. We are currently working on a more generalized version under the Fair by Design banner, where we also try to capture other disciplines. But our expertise is in the life science, so if there are other disciplines that would like to use this, then we can collaborate to make certain packages for these fields. Well, the source is a Git repository. All the code is open, so everybody can have a look at it. And our code generator that we use for the API is from Ampusa, which you can find there. And with that, that's the end of my presentation. So if there are any questions, please let me know.
Thank you very much. Other questions? Here is well, I think this is, of course, more towards research, the talk, and research data management. And what I was wondering, because we make our data fair in order to be findable and reusable, and well, for research, but also for industry. And in this case, well, do you have a solution on how to help people to annotate data in a way that it's findable by other use cases? And one should also take into account, because, for example, you make some experiment, but you don't know which kind of observations can be important for another researcher, right? Maybe, for example, you measure something, how the river flows, but you don't measure the level of sun, and this kind of, and maybe for other researcher this is important. And how would you help both researchers to find what they can annotate their data without also spending too much on this,
there's a very small tipping point on when you try to keep it as minimum as possible, so that people can easily register the information. But that's why we also work with these packages, so that you can look, as for example, if you take the air package, there are maybe 100 different fields that can be of importance. Only a few are really required, but it gives people an idea, especially that it's important that you do this kind of information gathering before you actually start your project, or that you start before you start collecting samples, that you can see, these are topics that often are captured by people, and do I find that important or not? And based on those criteria, you can then, you might realize earlier on that, I should measure also the temperature. That's actually very easy to do. So why not take it with me? But if you did not see this form, you might have forgotten about it. So we have studies where they did it in wetlands, where we had these little nature ponds, but they just didn't capture the temperature because it just didn't occur to them to capture this information.
You don't do it.
So you need to have these templates in place to guide them, to steer them. But of course, when you are at a company, you can also sit with a group of people and create your own package, saying, okay, we have all these packages that are used in the public, but maybe we think it should be differently. We can take certain elements from package A, certain elements from package B, and create our own SME package for whatever field, and then say these are really obligatory. So internally, you can have different requirements than what is in the scientific field available.
Can you imagine you also can generate these forms or suggest some ontologies to use to annotate based on the data which is already in the system, like, or what people write papers about? For example, if you see that people write a lot about people write about microbes, they, for example, refer to temperature quite often, and you can already suggest for somebody who is doing this, maybe you want to record also this value.
Yeah, so what we're currently also working on is basically mining the entire metadata that's currently being registered. So we have these big repositories where genetic information is stored, and people manually attach metadata to it. It's very unstandardized, but we actually try to collect all this information to see what is commonly used in the fields, and based on that we can then learn what should be applied in your data sets as well. I see a question from Amaya. So how do you finance the maintenance of the website, and what is your business model? So Unlock is a governmentally funded research project and will be funded for 10 years. So we are now in year 1, so we still have at least 9 years of funding left that we will definitely stay alive, and it will stay in development. In addition, everything is open source, and we actually try now to connect with the scientific community or with companies and with researchers to see, can we bring this to a higher level so that it's not only an Unlock solution, but that is more broadly applied into the field so that more people are going to use it, and then hopefully based on that, we will have a longer period to stay alive. But also in our department where we do a research, we already see the impact of this internally. So internally we will keep supporting this because we need it to collect the metadata when we start writing scientific articles, or when you want to share your information with other people. You need to have a way of capturing this information. So this will probably stay there for a very long time.
Are there more questions? All right, so then thank you very much for the presentation. Then we move to the next part of the remaining part of this session, which we basically will have a discussion more in free form, well, in semi-free form, because I already have some starting points for this. And right, so we stopped at the agenda, and well, basically this session is a part of Demonstrators work package. So in OntoCommons we have different work packages dealing with, some of them deal more with technologies, and this particular one which we lead deals more with demonstrators, about helping them to adopt ontology technologies, and also to understand where are the road blocks for this, and also to create towards creation of a roadmap on what we should be doing. And for this we already have some demonstrators. Well, 2 of them you have seen from BOSCH and from TEKNIKER, but we have already a few more that work with us on these topics, and also we are extending now the consortium towards more demonstrators. So generally, well, we start with this 11, and then we try to identify, basically, well, we do specifications for them and see how they develop also over 3 years of time in the project, and what they succeed to use and or not to use, and also, of course, they are also interacting with work packages that work on, particularly on tools and on ontologies in the OntoCommons, and we try to find ways to basically raise technology level readiness levels and raise FAIR levels, and then we record everything and see what basically goes on and what runs well and what runs not so well in order to have the best practices. So there was also a call for demonstrators, so maybe some of you who are here also applied and to join as a new demonstrators to basically help us to create this common vision and common picture to make ontology technologies more mature. So we are closing this call now, and well, if there is some interest to join actually us in producing this roadmap, you can still apply. We would still try to integrate you. Of course, the links are found on the OntoCommons website. But right now, I would just maybe first ask if the audience has actually any kind of general questions to all speakers about, well, we have heard 3 talks, and if some maybe general enough question which was not answered, we can ask, you can ask on some of the things. Because when no, I would go and discuss the things which are interesting from this work package point of view, particularly while we talk this in terms of technology readiness levels. We have making ontology adoption, and we have also the question, well, basically what works well and what works well not so well. And especially in the OntoCommons projects, we have people, also work packages working on with top-level ontologies, with mid-level ontologies, with domain ontologies, and with the various semantic tools deployment. And so this is the maybe well, a starting point, or at least at this point of time, would be very interesting to know. And especially we want to have interaction between different work packages working well, that demonstrators really get help from others on specific topics. And we already from the first, because we already did the first round of interviews with demonstrators, and we had some topics, well, for example, many demonstrators were mentioning they would want to do, for example, collaborative ontology development, but tools for this were not very advanced, and some further feedback like this we were getting. But I think, well, we have more also people on this session, so audience also can actually comment, and well, I don't know, maybe we can even turn on some also people from audience to speak. Also, for example, with top-level ontologies, we were often observing that people often don't use them, and hard to explain why. Maybe they don't see immediate benefit, and but then how to change the situation is also interesting. Something interesting to think about. Maybe we can start with the the speakers from this session. If you have, well, how would you classify your major challenges with using adoption of ontologies and adoption of ontology tools, or where would you need like help immediately in the near future?
Yeah, so what we actually see from our end is on the technical side, it's okay to incorporate existing ontologies and to use them to a certain extent. There's still, of course, always elements missing, because not one ontology is perfect. But actually, the most complex part is from the user side, that they actually have to start using it. So how do you force people to start using your infrastructure, to use those ontologies, to register? For example, in our case, with this metadata, how do we force them to register this information properly? So we can make the most amazing software and make the most amazing user interfaces, but then it's still at the personal level that they have to start feeding this information and actually using these systems, where the most difficult part is. Because it's a different environment that people are used to it. because yeah, everybody is familiar with Excel or with Word for these standard applications, but then you suddenly start to jump further, you create a boundary. And that what makes things a lot more difficult, because not everybody experienced with these technologies.
Mm-hmm. Do you think it's more like a technical challenge, or maybe Iker has a different perspective with a more manufacturing use case?
No, I would say that I also agree with Jasper, but maybe when you tell people that you are going to use ontologies, at first they panic a little bit, like, hey, I don't want to use this. So maybe it could be as simple as if you hide what's behind what you are using underlying your system. So that's why I was saying that we are planning to use an interface. Maybe users don't need to know what's going on behind behind the scenes. As long as it works, I guess that they will be happy, and maybe it's not necessary to to say the word ontology that they fear so much at times.
Mm-hmm. Do you think it's also a bit of a different, because if you take pure research, probably we want to make people use everything voluntary because they need it for their work. Well, in the manufacturing scenario, you can say, well, they are employees and they have to do it. So we have some challenge also, which is maybe non-technical, right, in some way, when it's not a production scenario.
Yeah, for example, for the part of making data fair, I think that there is that challenge on, I mean, why should they make the effort to produce the metadata, right? If they don't see a direct benefit in their work, it can be difficult for them, or for us to convince them to make it, especially if it's not in a like you said, in a manufacturing process or work where they are forced to do it. So yeah, I see there is a challenge there, and I don't I don't know how to address it in a convincing way.
Mm-hmm. Do you think is also the case? Well, sometimes it's yes, maybe with low-level worker at a production, you can say, okay, you will use this tool, and but with say upper management, well, for example, to explain them that they need to use top-level ontology because it's good for information integration in 5 to 10 years from now, maybe they won't be that convinced.
Yeah, you won't be able to convince them on that level for sure. No, but then indeed what Iker said is that you have to hide this kind of technology behind the scenes, so it will be adopted without people realizing it. And that's basically also in a way that how we use it with this Excel document. So we hide the technology behind it, so that only if you really want to go there on a technical level, you want to compare across studies or across projects, there is a possibility to use this technology to mine this information. But if you are just a scientist on your own or a researcher, you work on a small topic and you don't really care, you can still fill it in, but for you it's just an Excel file. And then you can hide it a bit on for the rest.
Mm-hmm.
If I understood the question correctly, I got disconnected for a few minutes. Then the question was on the top level ontologists and how to convince the people that it's a good thing, it's a useful thing, right? This was the question, yeah.
Yeah, it's something like when you don't see immediate benefit, but you know in principle it's good to use them because maybe your data integration will become simpler in the project, but maybe there is no immediate benefit. And how do you experience with this?
Yeah, actually, yeah, showing the ontologies or explaining ontologies as the technology may not be the most productive way, because I don't think they might be interested. They are interested in the technology details. to give an example, how one can convince that something is good, there is a Catena X project which is built on top of Gaia X, this European Data Spaces initiative. And in Catena X, the idea is to allow data sharing across the whole automotive value chain. So when this is what they want, is to improve the automotive value chain and to make it circular, to make it sustainable, to make all of these things work in a good way. And obviously, automotive value chain involves many producers, suppliers. It's a long value chain from resources to coming to cars, to tracing things, and then to recycling and so on. So there, in order to share data across, one needs standardized ways to enable this data sharing across. And whether these are ontologies or whatever else, that might not be that interesting for the management, but the fact that there is a technology, ontology-based technology that enables data sharing across the value chain, this is something that attracts attention. And definitely standardization of these artifacts across the whole value chain, this is very important, because obviously one would not like to have this value chain interconnected through artifacts where everyone creates these artifacts in whatever crazy way they think, or maybe not crazy way, I mean some other way they think, but it's ideal to have everything standardized across, connected to ISO standards, connected to good practices, and to be as standardized as it could get. Then whether these ontologies, top level, middle level, domain ontologies, or things like that, this would be secondary. The fact that ontologies as the technology allows to do data standardization, that's a big thing. One thing that I've heard also from people looking at this standardization across some domains, value chains, is that there is also a necessity to address legal aspects. For example, if you'd like to share data, and ontologies is a mechanism to share data, would be a mechanism to share data. How could you ensure the legal aspects surrounding the data, sharing the data, usage of the data, it's hard to imagine that ontologies do have these legal aspects embedded, but if they do, that would be also great. One could say that ontologies not only at the technical level allow data sharing, but they also allow you to negotiate about data, to set the boundaries of the data usage, to do all of the things that are necessary to be done in order for companies not to be afraid of sharing data. That's another thing. Yeah, so that's. I think that's convincing not at this top level, whatever level ontologies, but on the benefits, and telling that standardization comes, and then also the legal aspects could be important.
But still, yes, it should be a convincing scenario. Yes, of course, legal aspects, yeah, they are the driver of many projects, especially when, for example, GDPR. Then people start to think how to work with it, and there are still solutions not there. And there is a chance basically to adopt these technologies using such scenarios, yeah. But probably we need to kind of a clear scenario, examples, descriptions also at the end, that for some specific sectors we have clear stories which people could follow at the end of the project.
Another thing that actually has a lot of success is the concept of digital twins, which has attracted really a lot of attention, and many people are convinced about digital twins. And this comes with this understanding this digitalization is inevitable. You digitalize a lot of things in manufacturing, talking from the manufacturing point of view, and then in making digital twins of physical processes, machines, and other things via some uniform standard is what is attractive. Ontologies, they can play this role of digital twins. Here again, when I talk about digital twins, one important question that will eventually come is how do you do simulation? Because this is one of the things that people would love to do with digital twins, is when you have digital representation of a factory, you would like to simulate to see how something behaves. Like if you plug a new robot into the place of an old one inside the factory, what would happen? That's this simulation thing, and actually talking about materials, also as one of the speakers mentioned about some materials. So the simulation of material, if you have some digital twins where material also play a role, some ontology of some processes with materials, then one would like to simulate it to understand some piece of plastic, how long it can survive in various like bending or some other aggressive situations. There's so various type of simulations that come with digital twins. So in this case, using ontologies for some benefits like this digitalization and digital twins, or data integration and sharing across, this will eventually come with aspects which we may not that often discuss in the ontology community, or never discuss, like the legal aspects or the simulation aspects, and how can one click a magic button on top of ontology and say, simulate for me something. Like simulate, like create some knowledge graph that can form ontology and that can show me the behavior of a system in the next 3 years, and check that on during these 3 years simulated data, there will never be some bad thing happening. Like there is no downtimes or something doesn't degrade too much or things like that. So that's another thing. So that's So that the digital twin, I think it's to kind of cut the long story short, digital twin is, I think it's also an important aspect to sell ontologies, not to call them ontologies in some cases, but to use the term digital twin might be also more appealing and more convincing.
Yeah, this is also a kind of scenario one can use. In Evgeny, we also use this term for living organisms because, for example, you can also model some nutrition aspect, for example, and then see what happens with a human if you feed him or her with potatoes the whole time and things like this. So we have projects like this as well, not on, well, with life sciences and nutrition. So it's similar to not only for manufacturing.
Digital twin. Please.
So we also have it on a more industrial level. It's on a farm level. So Wageningen University is a agricultural university. We actually have a digital twin. It is currently in development of a farm where we keep track of everything, what is happening inside that farm, what is happening on the fields, what's happening with the tractor. So everything is interconnected there. So we always have a digital representation of when should you do what, when, based on the input of sensors and information. So there also the digital twinning is a very important aspect in current research.
And do you do it with semantic technologies? Oh, sorry. And do you do with ontologies, your digital twins?
We are trying to. Well, it's definitely a separate research group. So we are pushing them towards semantic technology, especially for the metadata and information from sensors. But it's a slow progress because still the technology is not that widely known everywhere. So the adoption rate is still on a very relatively slow pace. So it's getting there, but not as fast as we would like.
I think it's also about capacity building, that people have to have skills in this area, and of course we need to teach some students before this happens. The more the better.
We are working on that.
Yeah, we are working on this.
Yeah. Actually, teaching students is a big thing, because if you look at the teaching curriculum in universities who teach things about data, then typically the teaching, well, the relational databases are taught widely. Database administrators, you can find them in essentially every university, people who graduate with computer science. So they do have some database background, but there's no SQL data, some semantic RDF. That's not the most popular thing in the teaching material. That's also
that's completely true. So I'm currently actually a course coordinator for linked data here at Wageningen University, and that's only for the last 2 years. Before that, it didn't exist at all. So there were some people doing things in semantic web or with linked data, with ontology. So, but mostly on a higher level research department. But it was not done at an educational level. So that is now coming, but it's a slow progress, and it really needs more attention.
I think another interesting aspect that can help in convincing to look closer at these semantics, digital twins, these kind of aspects is is the shift which is happening at the database end. If you look at the trends in the database technology, if you look at VLDB or some Sigma, some top databases where the main research is happening, there is a lot of trend to go from the classical data into the graph data. So the graph data, there is a lot of statistics showing how much attention it gets from both academics and also technology providers. And then the graph data, this is the one that is very naturally connectable to the concept of ontologies, digital twins, because then it comes to these knowledge graphs that can store production data, that can store some data that is generated during the run of some systems, and ontologies can describe digital twins on top of these systems. So that's also, at least this is one of the arguments that I also have in my portfolio of arguments, that the databases go into the graph direction very, very, very fast, very rapidly. Yeah.
Evgeny, there is a question for you.
Oh, yeah, sorry.
Do you see it on the expansion of digital twin topic? Maybe it's not clear for everybody.
Yes.
What's the connection and what is the relation between those two?
Okay, I can see on the screen, right? Digital twins versus ontologies. So digital twin, clearly digital twin is a concept. It can be quite vague, and there are many people, and many people have their own reading of this term, like the term big data. What exactly the big data is, and then depends on whom you ask, you get an answer. So the digital twin, one way of looking at the digital twin is this computer representable and storable and processable model of a system, for example, of a manufacturing robot, and aspect models are currently a very popular way of looking at digital twins, where you represent your machine, your robot, with various aspects or properties, and then you combine those properties in special kind of buckets, which is like these aspect collectors. And this is, I would say, if you look at the ABB and BOSCH and Siemens and in many big companies, aspect models are synonyms for the technology behind digital twins. So digital twins, from the semantic also point of view, representations in terms of classes and properties of for example, manufacturing equipment. So the connection is that digital twin as the concept can be implemented, can be realized with the help of ontologies or semantic technologies, and ontology, knowledge graphs, some kind of shackle constraints, various forms of these semantic artifacts combined together can represent a physical thing, and they can be the digital twin of this physical thing. I don't know whether it helps or makes it more confusing, this connection between digital twins. So digital twin is the notion of some digital representation of physical aspect, and ontology is one way of doing that.
And it's also well helpful because it's also explicit, so it's understood by both humans and machines, and humans can. And basically, you can also build some rule-based systems on top of this model if you do digital twins with semantics. So it's a good technology to use it.
Yeah, and I would actually look further than just ontologies. I would say semantic artifacts, because ontologies, they come with open world semantics, and in many cases this is not sufficient for the scenarios where you would need also to do data validation. For example, constraints, like for shackle is the W3C standard for constraints, they are also quite important. You would like to ensure that there is a robot with particular configurations, and then whenever you see data about the robot, the data should contain all the information that is obligatory. Ontologies cannot enforce that up to the degree which is required. So I would say these ontologies plus constraints plus knowledge graphs. So essentially, semantic artifacts, they combined, they could give this digital twin. They can help to make a digital twin. The notion of simulation is a bit tricky, which is typically expected to come together with digital twin, and how to connect simulation to ontology. That's not a very trivial thing to do, but yeah. at least a lot of things can be done with ontologies, constraints, and graphs. Yeah.
Yeah, and often I saw it's also often used in combination, for example, with machine learning and knowledge graphs with machine learning, for example, because yeah, its ontology is not always not necessarily fully enough to do it. It's still a very complex thing, digital thing.
Yep.
Good. I have one more question about how do I get the okay the question out of the box. I hope it was answered. Then maybe the very last point of discussion is well, it's somehow related to the previous point, but well, we had also a discussion on fair data session in earlier on. And what do you think, again, how to motivate people to make their data more fair? Is it in the same way on how to adopt technologies, just try to, for example, hide it and try to do tools which do as fair data as possible? And when do you think the data is, well, you think you are enough fair with the fairness? And what is your perspective? And what are the main roadblocks? Yeah, of course, we already discussed some, for example, if people are not motivated to do it, they don't get any benefit, they wouldn't do it, but maybe there are some more.
Yeah, what I encounter a lot when people talk about fair is that they state you have to do it for other people so they can reuse your data, they can work on your information that you've acquired. And that really is a roadblock already for the person to, yeah, I'm not going to do it for someone else. So we really need to find ways of, okay, how does it benefit you? So when you start recording, for example, in my case was with this metadata, when you actually start doing your research, it benefits the scientist or the person itself directly, because they have recorded everything nicely, everything is well documented, they can really immediately start using it, and they don't have to go back to their computer or their hard drive, the USB stick, to where was this information, where was this file. So in that sense, it benefits them directly, and indirectly, other people might benefit from it as well. So then you have a different goal in mind. You try to first help the person itself or the goal, yeah, what the topic is currently working on. And indirectly, it makes it more open, more reusable for other people or for other companies, for other researchers to use it. And I think that's a mindset that needs to change. That if you only say you do it for someone else, then people will throw up and say, no, I'm not going to, well, I'm not going to waste my time on for someone else.
Yeah, I agree. I agree with that. I think that it's sad to say it, but yeah, I think that many times, unless we see a direct benefit for ourselves or our company or whatever, we are not going to adopt this kind of technologies. And also, just like Anna said, I think we should provide people with tools or with services where they, I mean, with their minimum effort, they get to have like the most fair or as fair as possible their to get their data. I mean, you cannot expect them to dedicate a lot of time to have very complete metadata sets for each data set that they are using. So it should somehow be automatic or with very little human intervention, and also that works for a lot of different, let's say, data formats. So, for example, you can tell them that it will only work with certain data, because otherwise you are giving them some constraints that, and giving them some more options to refuse to use it.
Do you think we can end up with a recommendation for some tools? Well, for example, Jasper was showing one which probably works for number of specific, where, for example, you need to collect observations and document them. But do you think we can come up with a set of tools we can recommend, for example, for demonstrators with similar problems or with similar challenges? Or for example, what are you using or planning to use in your cases?
We are developing a tool that somehow eases the process of getting this metadata. Of course, we didn't know the work that Jasper was doing, so probably knowing that will help us a little bit more. We were very focused on fairness metrics, but related with the quality of the data, and we were thinking on just the three aspects that I said, with a tool that has the minimum human intervention as possible, as being as automatic as possible, and also which works with a variety of data formats. And I think that well, these three principles are the base for any tool. Of course, there may be many more things that should be taken into account, but in the end of the day, we have to, since it is something that the users may not see directly beneficial for them, unless the case that Jasper has just commented, we have to provide them with some tools, some services that are easy to use, and that they are the requirement, that the effort that they have to put into using them, it's the minimum.
Mm-hmm.
Yeah. Jasper, please go ahead. Yeah.
Yeah, I think what you said, basically what it boils down to is user friendliness is key. It needs to be low levels, straightforward to be used, and the first level will be that in the backend everything is hidden, so that this translation from a normal interface to a ontology or semantic layer behind it, and then there should be always an option for the more advanced ways that you can still approach this layer behind it. So you need to really separate these two entities.
Yeah, so probably there are tools for different user groups, right? Should be, or maybe the same tool with different access options.
A small comment, maybe not on the tools, but on how to make sure that the data, the ontologies they come with, that they do follow the fair principles. So give a couple of examples. You know, the schema.org is an ontology that one can use to annotate web pages, and if you annotate your web pages in the right way, using the right annotations from schema.org, then Google and some other big search engines, they can take your web pages, and then the search of your web pages will be improved. How to enforce web pages to be annotated? Well, if you're Google, you just say that I will not find your page in a nice way. That's it.
That's
you can annotate whatever way you want.
Schema.org.
Yeah. So,
because it's beneficial to use it.
So that's the thing. So if you would like someone to do something, then in this case, the higher power, like Google, just tell you, you're gonna annotate whatever you want, the way you want, but if you want to benefit from my search, then please do it the way I tell you. If for example, we have some, if there is like an international standard or whatever that requires data to be of particular kind or ontologies to be of a particular kind, otherwise they will be rejected, then that makes that may make a difference. At the moment, there is no strong ecosystem for, or there is no strong big player like Google that just tell everyone you do it, or I will ignore you. For example, in the DOM for Zero project that goes back to back with OntoCommons, where the goal is to develop data marketplace, and BOSCH, myself, we are members of this, we're also partners in this consortium, DOM for Zero. Their data has to be shared, and naturally, if in such
I think Evgeny is frozen, no? Okay, lost connection now. Okay, we actually need to wrap up in any case, but I think there are, of course, similarities with fairness adoption and with technology readiness level raising that we observed. And of course, well, easiness to use and added value are very key point everywhere. So then I would be wrapping up, I guess. Unfortunately, we lost Evgeny for the last minutes, but then we will take all this input also as an input to our roadmap, this discussion, and which is also useful and to help everybody to adopt ontology technologies in a efficient way. So I would like to thank everybody who joined the session today, and especially the speakers who prepared and discussed the topics. And we have a conclusion session today after starting at 4 o'clock. There is a return to the plenary, and we have there starting at 4 plenary session with presentation of Elisa Kendall of financial industry business ontology, and some of you even might have used it. Well, at least my team was using it in projects which have to do with adoption of GDPR and how you motivate people to share data, and obviously in relation to business, it's a very relevant ontology. So we can hear about this more in the following up session. And then we have a session summary where everybody gives a short, every chair of every session today gives a short summary of what happens in the session. And then we have also some poster presentation. And that would conclude the day for today. So again, thank you very much everybody for joining, and we hopefully then see each other again in a few minutes at the conclusion session of today. Bye-bye.